This is the second video for section 9.5, and we're going to be looking at the ratio test. Just as a recap, the ratio test will be your third test that you're learning. We already learned the nth term, which remember only tells us divergence, and that is if the limit of a to the n does not equal 0, then the series diverges. Geometric test, if you have a geometric series and your r is less than 1, then you converge. If it's greater than or equal to 1, then you diverge. And this is our ratio test. So it says, let this be a series of non-zero terms. Converges absolutely if the limit as n approaches infinity of a to the n plus 1. You can think of that as the next term divided by the current term. So you're dividing consecutive terms, and your terms are greater than 0. Non-zero terms means a sub n is greater than 0 or positive. So think when you're dividing consecutive terms, this is very similar to the geometric series. So for a geometric series, when you divide consecutive terms, that's how you find your r. And if your r is less than 1, then you converge. And notice this says if your limit of the division or the quotient of your consecutive terms is less than 1, then you converge. So this is just a little example. If you have terms like this, to find what your r value is, what you're multiplying by each time is you divide consecutive terms. So you take 2/3 and divide it by 2, and you get 1/3. 2/9 and divide it by 2/3, and you get 1/3. So that would mean this is geometric, and that would mean that your r is 1/3, which is less than 1. So you would say that converges. So that's helpful in helping you. You have a lot to memorize. This is helpful in letting you memorize how the requirements of the ratio tests work, because they're very similar to the geometric test. So it diverges if when you do this division, you're greater than 1. Similar to geometric. If the limit equals infinity, you also diverge. And then if the ratio equals 1, then your result is inconclusive and you can't use the ratio test. You have to find a different way to figure out convergence. So this is a little different than geometric, because geometric, if you're equal to 1, you diverge. Ratio test, when your series have factorials or exponentials, those are going to be good problems to use ratio test on. So keep that in mind. So determine if this series converges or diverges. So this is an exponential. Remember, 2 to the x, 3 to the x, 1/2 to the x, 5 to the x, or to the n in this case. That's an exponential. That's an exponential. So I would start with trying ratio test on this. So the way you want to think about doing ratio test is, this is our a sub n. So we want to find a to the n plus 1 is where we want to start with these problems. So wherever there's an n, replace it with an n plus 1. So it's going to look like this: n plus 1 times 5 to the n plus 1 divided by 3 to the n plus 1, which would be, I'm just going to write it as n plus 2. Okay, so that's a to the n plus 1. So now I want to take the limit as n approaches infinity, absolute value of a sub n, which is, we want to do, here's what we want to do. We want to do a sub n plus 1 divided by a sub n. But writing this out, you can already see, will be a little bit of a pain. I'd have to write this, and then do a big division bar, and then write this. This is my a sub n. And then when we're dividing fractions, we normally do keep, change, flip. So I'm just going to do keep, change, flip from the beginning, and you're probably going to want to do that also, because otherwise these problems are going to get kind of long for you. So if I'm dividing, I want to keep the first fraction, change to multiplication, flip the second fraction. So I'm going to start with writing a sub n plus 1, change to multiplication, multiply by the reciprocal of a sub n. So this is what it's going to look like. Here's my a sub n plus 1. So I'm going to copy that. Times, so that's my keep. Now I'm doing my change. Now I'm going to do my flip. I'm going to take the reciprocal of this fraction. So 3 to the n plus 1 is going to go on top, and n times 5 to the n will go on the bottom. Okay, if you want to add a little note here that where this came from, it came from keep, change, flip, you could do that. All right, let's keep going. This is a limit. You do have to use proper limit documentation everywhere on the AP test, so keep that going. Now let's see if there is some stuff we can simplify right now. So think this is, well, I'm going to write one more in between step there. I'm going to rewrite these. This is the same as n plus 1 times 5 to the n times 5 to the 1 over 3 to the n times 3 squared. And then when we're multiplying fractions, you can think you're multiplying your numerators and multiplying your denominators. So this is going to allow us to do some dividing out when we have the same number on the top and bottom of our fraction. So I wrote 3 to the n plus 1 is 3 to the n times 3 to the 1. I wrote n, no, that was just a copy. Okay, so now let's see what one's out here. So I have 5 to the n on the bottom and 5 to the n on the top. That's pretty nice. 3 to the n on the bottom, 3 to the n on the top. Not too bad. This is 3, this is 9. So that would become just a 3 on the bottom. When you're doing this, be careful. Make sure you remember what you have on the top and the bottom. So this is what I'm left with. Okay, let's write that limit now and see what we have. All right, on the top I have n plus 1 times 5. On the bottom I have a 3, and this would be over 1 to the n. I think I can take my limit now. So if you think n, well, I'm going to write it. This is also helpful and good practice. So let's write it so our n's are sort of together in the same fraction. So n to the 1 on the top and n to the bottom. An n on the bottom, I'm going to write like that. And then I'm going to write my constant terms over here. This is good for documentation, so you can show, well, the limit as n approaches infinity of this is same over same. That approaches 1. So now I'm taking my limit. So my limit is the absolute value of 5/3, which is positive. So that's just 5/3, which is greater than 1. So therefore, series diverges by ratio test. This is proper documentation. So don't say diverges, don't stop here, show all your work. You have to very clearly show that that limit is a number that you can say is greater than 1. Then say diverges by ratio test. Every single time you're using a test, you have to reference what test you are using. Okay, next example, we have exponents and factorials. That is a good indication that you're going to use ratio test. Start out by finding a sub n plus 1. So wherever there is an n, replace it with an n plus 1, which just denotes the next term in the series. Put it in your limit. All of these steps are required for ratio test. Don't skip any of them. Well, you could maybe skip writing that. You could go right to your limit. So remember, we're going to do our keep, change, flip. So we're going to keep our a to the n plus 1. And then we're going to flip our a to the n. Okay. Now, this is the same as the limit as n approaches infinity. I'm going to write this as 2 to the n times 2 over we'll do this in a minute. I'll do this in a later step. Keep that as n plus 1 factorial times n factorial. Oh, I wrote this wrong. This should have been 2 to the n, sorry. Over 2 to the n. Okay, so 2 to the n divided by 2 to the n. That is gone. Limit as n approaches infinity. So now I'm going to put these factorials together. So I'm going to put n factorial over n plus 1 factorial times 2 over 1. Keep everything as a fraction. So I just am rearranging this a little bit. Remember, this is what's left. Don't forget that 2 on top. Now we're going to talk about how we can simplify that. I'm going to do it within the limit. Okay, so n factorial. So factorial means multiply by the number 1 less than the one you're working with. So if I'm starting with n and I'm doing factorial, I would multiply by n minus 1. So this is a way to write n factorial. N times n minus 1 times n minus 2, and then I could just stick a factorial on the end. Now let's think about n plus 1 factorial. Would be n plus 1 times 1 less than that, which would just be n, times 1 less than that, which would just be n minus 1, times 1 less than n minus 1 would be n minus 1 minus 1, which would be n minus 2. And then don't forget, we still got that 2 over 1. Now you can kind of see what's happening here. N minus 1, n minus 1. N minus 2 factorial over n minus 2 factorial, 1 out. N divided by n is just 1. So my factorials are gone now. And what I am left with is 1 over n plus 1 times 2 over 1. This, as n approaches infinity, this would approach 0. Oh, yes, that would approach 0, and 0 times 2 is 0, so my limit is 0. So this is less than 1, so series converges. By ratio test. All right. We've got a couple more examples. Last part is using the ratio test to determine the radius of convergence. So that is, remember back here, we're going to use the ratio test to find out where we are converging, or ratio test for determining radius of convergence. Remember, we are not doing anything with the endpoints at this point. So this says, this is again, you can think the next term divided by the current term. So if the limit is infinity, the series converges only at its center and the radius of convergence is 0. If this limit is 0, it converges for all x's and the radius of convergence is infinity. If you get a number, then that will help us determine the radius of convergence. So the best way to figure out this is to look at examples. I just wanted to make a note that this isn't a fraction. So this is going to grow fast. And check your directions. This doesn't ask you to figure out if it converges or diverges. It just says find the radius of convergence. So they're sort of telling you, hey, we know it converges. Find the radius of convergence. So I'm going to do the limit as n approaches infinity. I'm doing my n plus 1 here. It's not a fraction, so I don't have to do keep, change, flip. So this is going to be n plus 1 factorial over x to the n plus 1 over n factorial. x to the n. So limit as n approaches infinity. All right, remember your factorials are, if I take that factorial and just start writing out terms of that factorial, this is what I have. 1 less than n plus 1 would be n. 1 less than n would be n minus 1. And then I'm going to stick my factorial on that. N factorial would be n. 1 less than that would be n minus 1. I'm going to stop because I can already see where those match. And then on the top, I have x to the n times x over x to the n. So x to the n and x to the n, 1 out. N minus 1 factorial and n minus 1 factorial, 1 out. N and n, 1 out. So I am left with the limit as n approaches infinity of, what am I left with? N plus 1 times x. Okay, now be careful. This is n approaching infinity. Don't start plugging in infinity here. This is n approaches infinity. So if n approaches infinity, this term would become infinity, and my limit, whatever my x value is, remember it's just a number, infinity times an x value would be infinity. So if your limit equals infinity, you would say this series converges only at center, and the radius of convergence is 0, or no radius of convergence. It only converges at the center. Okay, let's try the next one. So this one is a fraction. By the way, this is the most common type when you do have the fraction. So limit, so I am going to do the keep, change, flip on this one. Oops, sorry, I'm jiggling the camera. So limit as n approaches infinity, n plus 1. So I'd have n plus 1 times x to the n plus 1 over 4 to the n plus 1 times the reciprocal here. So that would be 4 to the n over n, x to the n. Okay, limit, do some simplifying now. N approaches infinity, n plus 1 times x to the n times x to the 1 all over 4 to the n times 4 to the 1 times 4 to the n over x, x to the n. Let's do some oneing out here. 4 to the n divided by 4 to the n gives me 1. X to the n divided by x to the n gives me 1. That should not be an x. That should be an n. Apologize for that. So I'm left with a 4 on the bottom, n plus 1 on the top, and n on the bottom. So limit as n approaches infinity. I'm going to put the n's together. N plus 1 over n times, oops, I have an x up there too, times x over, oh, there's my n, x over 4, sorry. I think I can take my limit now. This is same over same, so that's going to approach 1. 1 times x over 4. My limit is absolute value of x over 4. 4 is already positive, so I can take that out of my absolute value. So this tells you it converges when this is less than 1. So this is like case 3 up here. So you get a limit, and you're saying it will converge when that limit is less than 1. So I'm going to say this over here. So this implies it converges when absolute value of x over 4 is less than 1. So let's solve for x to find the x values when it converges. So if I multiply both sides by 4, I get absolute value of x is less than 4. And remember, absolute value means I have two solutions, 4 and negative 4. So another way of writing this is saying x is between 4 and -4. So this is my interval of convergence. And my radius of convergence is 4. So that is your radius of convergence. Okay, looks like we have one more. It's probably going to be the other case, right? Where the radius of convergence is infinity, because I think we're looking at one of each of these. All right, limit as n approaches infinity. A to the n plus 1 would be x minus 1 times 3 to the n plus 1. Make sure you write it like that, because you have to distribute that. All over, I'm going to put this in brackets, 3 to the n plus 1 factorial times reciprocal of a to the n, 3 to the n factorial over x minus 1 to the 3n. Okay, let's keep going. Limit as n approaches infinity. All right, let's see, what do we want to do here? Let's write this as x minus 1, 3 to the n plus 3. So I'm distributing that 3. Let's write this as, I think I'm also then going to move this over here. So I'm matching up these terms. X minus 1 to the 3n. That will help me simplify in my next step. And then let's put our factorials together. So 3 to the n factorial over, again, distribute that 3 to the n plus 3 factorial. Okay. Limit. So this x minus 1 to the 3n, you can kind of think this is going to 1 out, and I'm going to have x minus 1 to the 3rd. So now I have x minus 1 to the 3rd over 1. And then I need more room to see what's happening here, so I'm going to copy that for now and do that on the next line.